move to the deck and reinforce what we have already learned. In the whiteboarding section, I described what is a public IP address and what is a private IP address in some detail. Apart from this, we also have individual lessons coming up on bring your own IP address and IP pools. So the focus of this lesson is on public IP address and private IP address. So first, let's look at private IP address. As I mentioned, every instance that you are going to have will have at least one primary private IP address. And that private IP address can have an optional public IP assigned to it. So in case of a public subnet, if there is an instance, it will have both private IP address as well as a public IP address. Now every VNIC I mentioned can have one primary private IP address and 32 secondary private IP addresses. And this is what you see in this diagram. So this is an instance. You have primary VNIC. If you just have primary VNIC, there is going to be a primary private IP address, 1. And then you can also have up to 32 secondary private IP addresses. If you have another secondary VNIC, then it is again going to have a primary private IP address and up to 32 secondary private IP address. So this is what we actually discussed. Now looking at public IP address, I mentioned that it's an IP address that is reachable from the internet, and it is always assigned to a private IP object on the resource. There are some conditions in order for the public IP to be reachable over the internet. The first condition is there must be internet gateway created in the VCN. Apart from the internet gateway, the public subnet should have the route tables correctly configured. That means there should be a route out to the internet through the internet gateway. And then you should also have correctly configured security lists. And as we have seen in the whiteboarding, each resource can have multiple public IP addresses because there can be one VNIC or there can be more than one VNIC. Every VNIC is going to have one primary private IP address and up to 32 secondary private IP addresses, and each of these private IP addresses can have a public IP address. We also discussed the different types of public IP addresses. The first one is ephemeral, which I mentioned is temporary and it goes away when you terminate the instance. The second one is reserved, that exists beyond the lifetime of the instance. So even if you terminate the instance, you can still have that IP address assigned to another resource. And the best part about this is there is no charge for using public IP address. Even if you have a reserved public IP address which is unassociated with any resource, still you are not going to be charged for it. So this marks the end of this lesson on IP management overview. Thanks for watching. Welcome to this lesson on reserved public IP addresses. In the previous lesson, we had a discussion on the two types of public IP addresses, ephemeral and reserved. So let's talk about reserved public IP addresses in some detail. So let me talk about reserved public IP address. As the name suggests, and we have already discussed, that this is going to be a persistent IP address. That means even if you terminate the instance, this IP address is going to exist beyond the lifetime of the instance. Now we'll talk about some details. The first detail is with respect to creation. So you can create reserved public IP address one at a time. So creation is one at a time. And then after it is created, you can perform the assignment. There is also a limit associated with reserved public IP address. You can have 50 reserved public IP addresses in a region. So we talked about assignment. What about unassignment? So if there is this reserved public IP, let's say this is the object. In case you would like to unassign it at any time, then that particular IP address is going to return to the tenancies pool of reserved public IPs. So there is no concept of automatic deletion. It is actually never automatically deleted. It is going to exist until you delete it. Another important thing is the scope for reserved public IP address is regional, which means it can be assigned to a private IP in any availability domain in the region. Let's say there is an instance. This instance has a VNIC, and we have discussed this VNIC can have one primary private IP address and up to 32 secondary private IP addresses. Now, there can be multiple VNICs associated with the instance. If we are moving any of the private IP addresses, let's say one of these secondary private IP addresses, we are moving from VNIC 1 to, let's say, VNIC 2. Now the reserved IP address will also move along with the private IP address. Please also make a note of this. This is also an important point. All right, now let's move on to the deck and quickly revisit what we have discussed. So as you can see in this screenshot, when you create a reserved public IP, you need to provide a name, then you need to select the compartment and the IP address source. In this case, the IP address source is Oracle. So it is persistent, meaning it is not ephemeral. Even if you terminate the instance, this reserved public IP address is going to persist. You have the ability to unassign and reassign to any other resource whenever you like. So that flexibility is there in reserved public IP address. And as we discussed, there is no concept of automatic deletion in reserved public IP address. It is going to exist until you delete it. And then this reserved public IP address also gives you the flexibility of assigning it to the compute instance or assigning the public IP address to any resource whenever needed. And thereby it reduces the security risk. This marks the end of this lesson. Thanks for watching. Hello and welcome to this lesson on Bring Your Own IP Address. Business days. Hello and welcome to this lesson on Bring Your Own IP Address. Let's get started. Let's say I am working with a public IP address in Oracle Cloud Infrastructure. So can you tell me who is the owner of that public IP address? It's basically owned by Oracle. Now let's say this is your on-premises environment, and let's say this is OCI. In the on-premises environment, you have an IPv4 CIDR or an IPv6 prefix that you would like to move to Oracle Cloud Infrastructure. Why? Because you might have an application where you have hard-coded IP address. And when you plan a migration to Oracle Cloud Infrastructure, you would like to use that IP address. Basically, if you want to have a smooth migration to OCI, you need to have a solution that provides solution continuity. And that is where this bring your own IP comes into action. So what is the process of bringing your own IP to Oracle Cloud Infrastructure? I will describe you the process in detail, but at a very high level, when you specify to Oracle that I need these CIDR blocks or these prefixes to be brought to OCI, Oracle is going to perform a validation. And what is the validation all about? The validation is regarding whether you are the owner of IPv4 CIDR block or IPv6 prefix that you want to import into OCI. And this ownership of these IP addresses, it must be registered with a supported regional internet registry. So in a nutshell, Oracle validates the ownership of your addresses before it can bring those addresses to OCI. Now there are some limitations, of course. For example, when it comes to IPv4 CIDR block, the minimum is /24 and the maximum is /8. When it comes to IPv6, the imported IPv6 prefix must be /48 or larger. Let's have a look at the bring your own IP process overview. So what is bring your own IP process and how does it look like? First of all, you as a customer, you will request. So first of all, you will request to import a public IPv4 CIDR block or IPv6 prefix. And remember, this is something that you own. So you request to import into OCI. Now, when you do that, Oracle is going to issue you a verification token. This verification token will be used by you. Basically, you will be adding the verification token to the information about your IP addresses that is kept by RIR. And RIR, I already mentioned, it stands for Regional Internet Registry. So let me mention it. It is basically add verification token to the info that's already there regarding your IP addresses in the RIR. After that, you also need to create something that is known as ROA. And ROA stands for Route Origin Authorization. What is the significance of this route origin authorization? If you don't create a route origin authorization, what can happen? As a part of route origin authorization, you provide the Oracle BGP ASN for the commercial cloud to the regional internet registry. And this ROA allows Oracle to advertise the bring your own IP CIDR block. So this is a pretty important step. After that, you request that Oracle finish the import process or the import request. And this typically takes around, remember, I talked about the verification token, adding the verification token. This takes around 1 day. So after this, Oracle is going to communicate with the RIR and it is going to verify that you own the IP address. So that's the validation process. So after that, Oracle is going to provision the bring your own IP addresses to your compartment within your tenancy. At this point of time, you have the bring your own IP IPv4 CIDR block or IPv6 prefix. So that is basically yours to manage in your compartment. What you can also do is you can also advertise this CIDR block or the prefix to the internet. So this is how this process works. So let's now move to the deck and discuss about bring your own IP. So as I mentioned in the whiteboarding, you have the ability to bring your own IP address space to Oracle Cloud Infrastructure so that you can use them with your resources in Oracle Cloud Infrastructure. I also mentioned that Oracle is going to perform a validation process on the imported IPv4 CIDR blocks or prefixes, and after validation, you will be notified that they are available for advertisement. I also talked about RIR, which is Regional Internet Registry. So the IP addresses that you plan to bring to Oracle Cloud Infrastructure must be registered with a supported regional internet registry. And Oracle is going to validate the ownership of your addresses at regional internet registry. As far as the limits are concerned, I mentioned that you can use bring your own IP with an IPv4 CIDR block that is minimum of /24 and maximum of /8. And when it comes to importing IPv6 prefix, it must be /48 or larger. And after the process is successful, you can manage IP addresses through IP pools. And remember, this is just for IPv4 addresses. So let's talk about the benefits of bring your own IP. The first benefit is if you have IP address hard-coded in devices or built architectural dependencies on specific IP addresses, using bring your own IP, you have a smooth migration to Oracle Cloud Infrastructure. So in a way, it brings solution continuity. It also provides the ability to summarize groups of IPv4 addresses into pools and to create resources for deployment, such as load balancers. Some internet services also rely on a contiguous IP address space, and hence it also provides benefits like IP reputation. Now let's look at the workflow. Although I have explained you in the whiteboarding, let's quickly go through it one more time. The first step is you request to import a public IPv4 CIDR block or IPv6 prefix that you own. In the second step, Oracle is going to issue a verification token. Now you need to add the verification token to the information about the public IPv4 CIDR block or IPv6 prefix that is kept by your regional internet registry service. And this process can take up to 1 day. You also need to create a route origin authorization, which is also known as ROA, with your regional internet registry or RIR. As a part of the ROA, you need to provide the Oracle BGP ASN, and the ROA allows Oracle to advertise the bring your own IP CIDR block. Now you have to request that Oracle finish the import request, and this workflow can take up to 10 business days to complete. And Oracle is going to communicate with the RIR, and it is going to verify that you own the IP address. After that, Oracle is going to provision the bring your own IP addresses to your compartment within your tenancy. At this point, the bring your own IP, IPv4 CIDR block, and IPv6 prefix is yours to manage in your compartment. You can also advertise the IP address blocks or prefixes to the internet. So this is the workflow for bring your own IP. I hope you understood the workflow for bringing your own IP to Oracle Cloud Infrastructure. Thanks for your time. Welcome to this lesson on public IP pools. Let's get started. Let's say this is your bring your own IP CIDR block. Now what you want to do, you want to create a public IP pool. So what is a public IP pool? It is nothing but it is a set of IPv4 CIDR blocks. And what is so special about this public IP pool? Because it is allocated to a tenancy. So it is allocated to a tenancy, and it can be a part of bring your own IP CIDR block, or it might be the entire bring your own IP CIDR block. When I say allocated to a tenancy, it basically means that it is available only for your tenancy. In case you want to use public IP pool, the first thing that you need to do is you need to import your addresses. And what is the benefit of adding IP CIDR blocks to a public IP pool? The benefit is you can create a reservation. So you can create a reserved public IP. And what will you do with this reserved public IP? You can attach it to your resources. So resources like NAT gateway, it can be load balancer, or it can be compute instances. So you can create a reserved IP. The second option you have is you can enable direct launch from pool. So instead of reserving IP for a particular resource like NAT gateway, you can launch resources with an IP, and that IP is going to be directly allocated from a public IP pool. So that is also possible. So you can create a reserved IP and then attach to your resources, or you can directly launch from the pool. So let's look at the deck. And one thing to note here is that currently it is a set of IPv4 CIDR blocks that is allocated to a tenancy, and IPv6 addresses that do not use the IP pools functionality. So it's a set of IPv4 CIDR blocks that is allocated to a tenancy. And when I say allocated to a tenancy, it means that it is available for your tenancy only. So first of all, you need to bring your own IP address, and then you can create a public IP pool. You can make the entire bring your own IP CIDR block the part of the public IP pool, or it can be even a part of it. So the best part about this, just to reinforce, it is only available for your tenancy. And then I mentioned there are two choices. The first choice is you can create a reserved IP from your public IP pool, and then that reserved IP can be attached to your resources. The second option is you can directly launch from the pool. That means you don't need to create any reserved IP, directly launch resources, and the IP is going to be directly allocated from a public IP pool. And that is what I mentioned. There are some limits and quotas, as you can see in the slide. When you create a public IP pool, it can have 0 or more IP CIDR ranges, and the minimum size range is going to be /28, and the maximum size is going to be /24. So with this, we wrap up this lesson on public IP pools. Thanks for watching. Hello and welcome to this demonstration on IP management. So let's get started. I'll take you to the OCI console, and first I'll take you to the compute service to compute instances. I already have a VM that is running. you can see that OCI instance. So I'll click on it. If you scroll down under primary VNIC, you will see that this has a public IPv4 address and a private IPv4 address. So I'll scroll down and under resources, I'll go to attached VNICs, and here you see that there is the primary VNIC that we discussed in the lesson. This is the primary VNIC and the state is attached, right? So I'll click on the primary VNIC. That will take me to the primary VNIC page. So here you will have all the information related to VNIC. If I scroll down under resources, click on IPv4 addresses. Here what you see is the primary private IP address for this VNIC. You also have the option to assign secondary private IP addresses. So if I click here you can specify the IP address. Even if you don't specify, then Oracle is going to assign one for you. And this is where you do the mapping of the private IP and the public IP. So if I don't specify anything and click on assign, let's see what happens. You see, this is the secondary private IP address that has been created for this primary VNIC. This is the primary VNIC. And you see that the public IP address corresponding to this private IP address is currently not assigned. For the primary IP, there is a public IP address which is ephemeral in nature. So if I click here, I can edit it, and if I want to have a public IP type, I can just click on reserved and I can create a new reserved IP address, and I can specify the type as Oracle and I can give it a name. I can update it. So this way, now you see that first of all, we are inside the primary VNIC. In the primary VNIC, there is one primary private IP address, and then there is one secondary private IP address. And you also see that this public address is ephemeral. This one is reserved. Okay, so now I will take you to this navigation menu. Click on networking. And you see there is something called IP management. So click on IP management. Under IP management, you will be able to see all the services that we covered in the lesson. For example, the concept of reserved public IP address and how is it different from ephemeral IP addresses. So if I click on reserved public IP, so this is the same IP that we reserved a couple of minutes back. How do we reserve public IP address? So let me call it test reserve public IP. And you need to define an IP address source. As of now, we have just one source, which is Oracle. So I'll click on Oracle and I'll click on reserve public IP address. So now you see that this reservation is done and this is the public IP address. Now what can we do with this public IP address? Let's say I want to create a NAT gateway. So I'll go to the VCN. I'll go to demo VCN. If I go to NAT gateway, create NAT gateway. Here there is an option to select ephemeral or reserved public IP address. So I'll click on reserved public IP address and I will select existing reserved IP address. And this is what I will select, test reserved public IP. Click on create NAT gateway. All right, so I have shown you how you can create a reserved public IP address and use it while creating NAT gateway. Now returning back to the IP management. So I have shown you this reserved public IP address and you see the state as assigned. If you click and create another reserved public IP, you select Oracle as the IP address source. And you can also see the difference in the state. This says available, but these two say it's assigned. Assigned means it is associated with a resource. This one is associated with the VNIC or the instance, and this one is associated with the NAT gateway. So this is how you can work with your reserved public IPs. Now there is another concept of bring your own IP that we discussed, and we also talked about the flow. Just to show you how it looks like, click on import bring your own IP, CIDR block or prefix. Here you need to give it a name. This is the compartment, and this is where you need to provide your CIDR block. Just as a sake of demonstration, I am not the owner of this public IP address, but just to show you the process, I provide the IP CIDR IPv4 CIDR block, and I click on import bring your own IP CIDR block. Now what happens next is it would go to a state of creating. If I click here, you will be able to see the validation token as I mentioned in the lesson, and you need to register this token with your RIR, which is Regional Internet Registry. So after you register your token with the RIR, then need to do is you need to click on finish import. So after you register your token, and you can also follow the steps in this particular documentation, let me quickly show you. So this documentation talks about the entire process. For example, import bring your own IP CIDR block. You enter the IPv4 CIDR block, and then it basically generates you with a token. And then you also need to create a route origin authorization object that authorizes Oracle to advertise your CIDR block. What are the steps to create the route origin authorization depending on the RIR? So you can have a look at that. After completing all these steps, you have to click on finish import. You see there is an option finish import, but this should be completed only after you complete these previous steps. After the validation is done, you have an option to advertise the CIDR ranges. So this is how bring your own IP looks like. And returning back to the IP management, there is one thing that I have not shown you till now, which is public IP pools. So let me click on public IP pool. Let me click on create public IP pool. This is a feature that will work only after you bring your own IP. So after you bring your own IP, you need to create a public IP pool. Let me click on create public IP pool. If I go inside the public IP pool, as I don't have a bring your own IP CIDR block, so it is showing empty. Once you have the CIDR block, then you can go ahead and you can reserve public IP addresses, right? So this gives you a message that this public IP pool does not have an associated CIDR block. And from where will the CIDR block come? When you bring your own IP, right? You can use the portion of it, or you can use the entire CIDR block to create the public IP pool. One last thing that I will show you is if I go back to reserved public IP address, now here under IP address source, you should be able to see two because we created a public IP pool as well, right? As of now, it is not associated with a CIDR, but as you bring your own IP CIDR, then you can basically select this IP address source and you can reserve a public IP address. All right, this marks the end of this demonstration. Thanks for watching.
Welcome to this module on networking connectivity. Now that we know what is a VCN and what are the core constructs of a VCN, it's time for us to look at connectivity. Let's say you have a VCN. How can you connect this VCN to another VCN in the same region? And how you can connect one VCN to another VCN, let's say this time the VCNs are in different region. So we will look at both these options. The first one is the concept of local peering, and then we have the concept of remote peering. And after that, we will also look at the options with respect to connecting an on-premises environment with your VCN. And for that, there are two options. The first one is site-to-site VPN connection, and the second one is Fast Connect. For both site-to-site VPN connections and Fast Connect, you require a dynamic routing gateway. So in this module, we'll also do a deep dive on dynamic routing gateway. So let's get started.
Welcome to this lesson on virtual cloud network connectivity options. Let's get started. So when we have a VCN, we can either connect this VCN to another VCN, which is in the same region, or we can connect the VCN to another VCN, which is in a different region. So both the options are supported in Oracle Cloud Infrastructure. When both the VCNs are in same region, we call that process local peering. And when the VCNs are in different regions, we call it remote peering. Now there are two ways in which you can configure local peering. The first option is you can use local peering gateways. The second option is you can also use dynamic routing gateway. We have dedicated lessons on peering, both local peering and remote peering in the upcoming section, but here I am just giving you an overview of what we can achieve. Then in case of remote peering connection, you can configure it using dynamic routing gateway. So this is with respect to when you need to connect a VCN to another VCN. If you would like to connect the VCN to your on-premises network, so this is basically the customer location or on-prem network. Now, if that is the case, here there are three options. The first option is you use public internet. The second option is you use something which is known as site-to-site VPN. So site-to-site VPN connection. And the third option that you have is Fast Connect. So in case of public internet, we typically use gateways like Internet Gateway or NAT Gateway. And then we can configure connectivity over the internet. In case of site-to-site VPN, it's basically an encrypted connection. So in terms of security, it is a secure connectivity over internet, IPsec VPN. But ultimately the traffic traverses over internet. So what it means is there is no throughput guarantee. And in case of Fast Connect, this one is dedicated connectivity. And when I say dedicated connectivity, it implies that you will get low latency and high bandwidth. So these are the options when it comes to VCN connectivity. You can connect your VCN to another VCN in the same region or in a different region. And then you can also connect your VCN to on-premises network. So as I mentioned, there are two options. You can configure local peering. You can also configure remote peering. So you see that here on the left, there are two VCNs in the same region, and we are connecting them via local peering gateway. So that is your local peering. And on the right, there are two VCNs in two different regions, and we are using dynamic routing gateway in order to facilitate communication between these two virtual cloud networks. Now, I also mentioned that there are two ways in which you can configure local peering. The first is using local peering gateway, and the second is using dynamic routing gateway attachments. Instead of creating two local peering gateways, you can just have one DRG, and if you connect both the VCNs to that particular DRG, you establish local peering. Now, one thing to note here is that although we are going to cover these topics in detail in the upcoming lessons, but after configuring peering, you also need to have appropriate route rules added in the route table. Now, when it comes to connecting on-premises to Oracle Cloud Infrastructure, there are three options. The first is public internet. Typically, the communication happens via Internet Gateway and NAT Gateway, and it is useful in scenarios where you need to conduct a POC. Because the traffic traverses over the internet, it is going to be unencrypted. However, you may apply some application level encryption. The second option is site-to-site VPN, where there is secure connectivity over the internet. So there is a secure VPN tunnel. Since the communication traverses over internet, there is no guarantee of the throughput. It is managed by Oracle Cloud Infrastructure, and it's a free service. Now, the third option is Fast Connect, where you get a dedicated connectivity between your customer location or on-premise network and Oracle Cloud Infrastructure. So dedicated connection means it is going to have low latency, and it's also going to be secure, as well as it's going to provide high bandwidth up to 100 Gbps. It's also an OCI managed service, and there is no egress data transfer charges. So it has a competitive pricing. The only thing that you have to pay is the port charges on an hourly basis. So this Fast Connect, it is suitable for business critical applications and also latency sensitive applications because it caters to both compliance and security requirement. So these are some of the considerations for cloud connectivity options. You see that for Fast Connect, as I mentioned, it has higher throughput. It provides low latency as it is a dedicated connection, which means it provides consistent performance. In case of site-to-site VPN, it is recommended for proof of concept. The connection is going to be encrypted, but ultimately the traffic will traverse through the internet. And in case of public internet, it is suitable for SaaS applications because the communication is going to happen using Internet Gateway or NAT Gateway. At the same time, it is going to traverse over internet. So this marks the end of this lesson. Thanks for your time. Hello and welcome to this lesson on local VCN peering. So let's get started. The first thing that I will help you understand is what is the meaning of peering and what is so special about VCN peering or local VCN peering. First of all, you should keep in mind that peering, there are two types of VCN peering. The first is local VCN peering. The second is remote VCN peering. In this lesson, our focus is on local VCN peering. So first of all, let's try to understand the meaning of the word peering. Let's assume there are two virtual cloud networks, VCN A and VCN B. If these virtual cloud networks, they want to talk to each other, there are two ways in which this can be done. The first option is you use public internet, which means inside the subnet there are virtual machine instances. Similarly, inside the subnet there will be virtual machine instances. These virtual machine instances will have public IP addresses and they will communicate with each other using public IP addresses. So that is the first option. The second option is there will be a private direct access. In this case, the communication is going to happen via private IP address. So these are the two options that we have. And because we are talking about local peering in this lesson, our focus will be on the communication between the VCNs within the same region. So what is the benefit? What is the key takeaway from this discussion? The benefit is when you configure peering, so the instances, they communicate with each other using private IP address. So let's now look at the two types of VCN peering or local VCN peering that we have. Now I will write local VCN peering and I will explain you the two ways in which you can configure local VCN peering. Even before I talk about that, it's very important for you to understand that when there is a VCN or virtual cloud network, basically we are talking about the different types of gateways. So you'll keep on hearing these terms. The first one is local peering gateway. Then we have dynamic routing gateway. These all are virtual routers, and we'll talk more about these in the upcoming lessons. But as of now, you understand that these are nothing but these are virtual routers. So in a VCN, you can have up to 10 local peering gateways, and you can attach one VCN with one dynamic routing gateway. But if there is a dynamic routing gateway, you can have up to 300 VCN attachments. Just like in the previous modules, we have seen there is something called internet gateway. Then we have service gateway. We have NAT gateway. Similarly, when it comes to connectivity, we have these different types of gateways. For example, local peering gateway, dynamic routing gateway. So one VCN can be attached to one dynamic routing gateway, but it can have up to 10 local peering gateways. Now let's talk about the two types of local VCN peering. The first type is local VCN peering using LPG, the gateway that I talked about previously. So local peering gateway. So this is the first type. How we can configure local VCN peering using local peering gateway. And the second option is we can also use upgraded dynamic routing gateway. So there are two ways in which you can configure local VCN peering. Let's break this word into two parts. Local means when we are trying to establish communication between two different VCNs, both the VCNs will be in the same region. That is what is the meaning of local here. And peering basically means you are going to connect the two VCNs. And when I say connect, I mean privately. So these are the two types of local VCN peering. Now you might ask why we have two types. The first answer to this question is, as you can see here, I have mentioned the word upgraded. So previously there was a dynamic routing gateway version 1. Now we have dynamic routing gateway version 2. But when we did not had dynamic routing gateway version 2, we used to connect two different VCNs within the same region using local peering gateway. And the benefit associated with this is it provides extremely high bandwidth and super low latency. The benefit associated with this is it provides flexibility in routing. And now you can understand what do I mean by flexibility in routing. In the previous whiteboarding discussion a couple of minutes back, I mentioned that if you have a dynamic routing gateway, you can configure it to be attached to up to 300 VCNs. While in case of local peering gateway, I mentioned that each VCN can be attached or can have up to 10 local peering gateways. All right, so this first approach provides extremely high bandwidth and low latency, and using upgraded dynamic routing gateway, there is flexibility in routing. So let's now talk about the first approach, and then we'll also talk about how we can configure local VCN peering using upgraded dynamic routing gateway. All right, this marks the end of part 1 of local VCN peering. We are going to continue the discussion in the next lesson. Thanks for watching. Welcome to the part 2 of local VCN peering. So now we are talking about how we can configure local VCN peering using local peering gateways. So to make things clear, I will draw an architecture. First of all, the two VCNs are in the same region. This is VCN 1. This is VCN 2. Now the first condition for peering is that the IP addresses should not overlap. So if this is 10.0.0.0/16 and if this is 192.168.0.0/16, these are non-overlapping IP addresses and hence they can be peered. So this is the first condition. You should have two virtual cloud networks with non-overlapping CIDRs in the same region. And what is the second consideration? You must have a local peering gateway on both the VCNs. So let's name it local peering gateway 1. This is local peering gateway 2. So you must have a local peering gateway on each VCN in the peering relationship. And then you need to have a connection between these two local peering gateways. So after you configure these all resources, the next thing that you have to take care is with respect to route tables. That means you have to create supporting route rules to enable the traffic to flow over the connection from this VCN to this VCN and vice versa. And you also have to create supporting security rules so that you can control the type of traffic that is allowed between the instances belonging to these two VCNs. But this is how this local VCN peering setup looks like. Remember, here there are two local peering gateways, and you also need to create a connection between those two local peering gateways. Now let's look at the second approach. Local VCN peering using upgraded dynamic routing gateway. Again, here what I will do, this is the region and there are two VCNs, VCN1 and VCN2. First of all, you will have two VCNs again with non-overlapping CIDRs. For example, 10.0.0/16. This is 192.168.0.0/16. So that's the first thing. And the second thing is you create something that is known as dynamic routing gateway. So you create this virtual router. And the point to be noted here is that you need to create only a single dynamic routing gateway. And this dynamic routing gateway will be attached to both the VCNs. So it will be attached to both VCN1 and VCN2. So instead of having two local peering gateways, in this case, having just one dynamic routing gateway will solve the purpose. And again, like the previous case, you need to configure route tables and security lists. And just to give you a sense of how the route table is going to look like, let's say you want to configure a route table for one of the subnets in VCN1. So for that, what is the destination and what is the target? If the destination is 192.168.0.0/16, that means VCN2 CIDR. If from here you want to go to VCN2, then the target is going to be dynamic routing gateway. Similarly, for this particular virtual cloud network, the destination is going to be this, and the target is going to be dynamic routing gateway. The final thing before I move on to the deck is, let's say there is no peering. Let's say we don't configure peering. If you don't configure peering, and then if you want these two VCNs to talk to each other, they will need an internet gateway and they will need public IP for the instances that are communicating. All right. So that was one thing that I wanted to highlight. Another thing, let's say these two VCNs are peered using local peering gateway. And let's suppose this VCN also has an internet gateway. Now the question here is, can this VCN use this internet gateway to send the traffic to internet? I hope you are following what I am asking. I am asking, these two VCNs, first of all, they are peered locally using local peering gateway. Now, instances in VCN1, can they connect to the internet via internet gateway, which is not present in this VCN, but is present in the peered VCN? What do you think? The answer is no. They cannot send traffic using internet gateway of a peered VCN. But the interesting part is, they can receive the traffic. All right, now let's quickly look at the deck and revisit some of the important concepts of local VCN peering. So there are two ways in which you can do local VCN peering. The first is using local peering gateways. So as you can see in the slide, there are two virtual cloud networks within the same region. And when we configure peering, the resources in the two VCNs can communicate with each other using private IP addresses. And to configure local VCN peering, we need a local peering gateway on each VCN. So that means there are a total of two local peering gateways that are required. One of the prerequisite for local VCN peering is that the VCNs should have non-overlapping CIDR blocks. And after you have the two local peering gateways on two VCNs, you also need to create a connection between those two local peering gateways. So after you have configured the local peering gateways and connected them, you also need to take care of the routing. And as you can see here, we need to add route rules on both sides. And you also need to set up supporting security rules. So this is how it is going to look like. We have already discussed this. So there is local peering gateway on both sides of the VCN, and then you have to create a connection between those local peering gateways. For this VCN, the destination is going to be this particular VCN. So we are adding it in the destination CIDR, and the route target is going to be local peering gateway 1. Similarly, for this VCN, the destination CIDR is going to be this particular CIDR, and that is what we are mentioning here. And the route target is going to be local peering gateway 2. Okay. So another way of configuring local VCN peering is by using upgraded dynamic routing gateway. So here, as you can see, unlike previous configuration, you don't need two local peering gateways. Rather, you just need one dynamic routing gateway. So you just need to create one dynamic routing gateway and then attach it to both the VCNs. So after the configuration is done, you also need to take care of routing as well as security rules. This marks the end of this lesson where we discussed local VCN peering. Thanks for watching. Welcome to this demonstration on local VCN peering. Let's get started. So what we will do in this demonstration is, firstly, we will configure local peering using local peering gateways, and then we will configure local peering using a dynamic routing gateway. So we will demonstrate both the approaches. So let's get started. Okay, so I am inside the OCI console, and first of all, let me show you the resources that I have created for this demonstration. Firstly, we have two VCNs, VCN A and VCN B. If I go inside the VCN, you will see that there is one subnet, public subnet. We have also created an internet gateway. You see there is an internet gateway, and we have made the changes in the route table. Destination 0000/0 internet gateway. So this is what we have done for VCN A, and same is the case with VCN B. One subnet, creation of internet gateway, and one entry in the route table. So from the VCN side, that is what we have done. What we have also done is we have created two instances. Instance A is created within VCN A, and instance B is created within VCN B. So before we configure the local peering, let me first connect to instance A. This is the public IP. I will just copy it. Okay, you see I am currently inside instance A. And now if I try to ping the private IP address of instance B, You see it is not working. So let me minimize it. Let's go to the virtual cloud network, VCNA, and create a local peering gateway. Click on create local peering gateway. So LPG1 is now created. I will go to VCNB and create another local peering gateway. This time I will call it LPG2. Click on create. So we have both the local peering gateways created. Now what you need to do is you can go to either of the VCNs. I'm going to VCN A, and now I'll go to the local peering gateway. I'll click here and click on establish peering connection. Remember, I am inside VCN A. So this time I'll select VCN B, and I will also select LPG2. Click on establish peering connection. So now you will see that the peering status is pending. It is establishing a connection to the peer. So what we typically did till now, we have created local peering gateway on both the sides, LPG1 and local peering gateway 2. And then we have created a connection between those local peering gateways. And the status that you can see now is peered. So now these VCNs have been peered. Now after this is successful, you know what to do. We need to configure a route table, and then we need to also configure security list before we try the ping. Okay, so this is done. So let me first add an entry in the route table. Currently I am inside VCN A, so I'll go to default route table. I'll click on add route rules. I'll select the target type as local peering gateway, and I will select the destination as okay. And for this destination, the target is going to be LPG1. Click on add route rules. Similarly, I will go to the VCNB route tables, default route table. I'll click on add route rule. Local peering gateway. This time the destination is 10.0.0.0/16 because I am inside VCN B. The local peering gateway is going to be LPG2. Click on add route rules. Remember, just one hint here. You are inside VCN B, and VCN B's CIDR is 192.168.0.0/16. This is the CIDR for VCN B. And from inside VCN B, if you want to send the traffic to VCN A, what would be the destination? The destination would be 10.0.0.0/16, and hence you have to send it to the local peering gateway for VCN B. So the routing has now been taken care of. Let me return back here, and just by configuring the route tables, do you think it is going to work? Let me try pinging it once again. You see it's not working. Why? Because we are yet to add a rule in the security list. So let's very quickly do that. I'll go to virtual cloud network. First of all, VCN A. Under resources, I'll go to security list. I will edit the default security list for VCN A. I will add an ingress rule. The source this time is going to be 192.168.0.0/16, and the IP protocol is ICMP. Click on add ingress rules. So done for VCN A. The same needs to be done for VCN B. Security list, default security list, add ingress rule. The source for VCN B is the CIDR for VCN A. The IP protocol is going to be ICMP, and add ingress rules. So now if we return back we will see that the ping is now working successfully. And remember, 192.168.1.189 is actually the private IP address of instance B. So from inside of instance A, we are able to ping instance B using private IP address. So now it's confirmed that our peering connection is successful. But this connection was created using local peering gateway. Now comes the second part of the demonstration where I'm going to show you how you can use dynamic routing gateway to configure local peering. So now we are back to square one, the way we started our demonstration. The only thing that is added now is security rules. So let's do one thing. So let me take you to the navigation menu, networking. Under customer connectivity, click on dynamic routing gateway and click on create dynamic routing gateway. So I will name it OCI Architect Associate Dynamic Routing Gateway. Click on create dynamic routing gateway. You see that currently it is provisioning. So I will wait for it to get provisioned and then I will show you the next steps. So now you see that this dynamic routing gateway is available. So let's create the VCN attachment. So first of all, I will create the attachment with VCN A. And then I will create the attachment with VCN B. So I'm attaching the DRG to both the VCNs. So now you see that the lifecycle state is attached. So this dynamic routing gateway is now attached to both VCN A and VCN B. If we return back to the instances, let me first clear it. And from inside instance A, we will try to ping the private IP address of instance B. You see that it's not working because we are yet to configure routing. So we'll return back. We'll go to networking, virtual cloud networks. Let's first go to VCN A, route tables, default route table, add route rules. The target is dynamic routing gateway. The destination CIDR is 192.168.0.0/16 and you are sending it to OCI AA DRG. Add route rules. Similarly, for VCN B, we need to do the same thing. Route tables, default route table, add route rule. The target type is dynamic routing gateway. The CIDR block is 10.0.0.0/16. Click on add route rules. Okay, so that is done. So if we return back to the instances, you see that now it started pinging. That means now the configuration works fine. So this marks the end of this demonstration where we looked at how we can configure local peering using both local peering gateways as well as dynamic routing gateways. I hope you found this demonstration useful. Thanks for watching. Hello and welcome to this lesson on remote VCN peering. Let's get started. In the previous lesson, we discussed about local VCN peering, which means connecting two VCNs in the same region. Now, in case of remote VCN peering, we will have two different regions. So let's say this is region 1 or region A. This is region B. We have two VCNs, VCN 1, VCN 2. So the process of connecting these two VCNs in different region is what is known as remote VCN peering. Now, when you configure remote VCN peering, the instances in VCN1 can communicate to the instances in VCN2 using private IP addresses. And the best part is the communication will happen privately. So the traffic won't be routed over internet. Now, one thing that you also need to understand is these VCNs, they can be in the same tenancy or they can be part of different tenancy as well. And same is the case with local peering. Even in the case of local peering, you can have peering between VCNs in the same tenancy or different tenancy. So now let's talk about the components that you need for remote peering. First of all, you should have two VCNs with non-overlapping CIDRs in different regions. Then you should have a dynamic routing gateway created and attached to each of these two VCNs. The next thing that you need to do is to create a remote peering connection on each DRG in the peering relationship. Then you need to have a connection between the remote peering connection. So there will be two RPCs and you also need to configure a connection between those two RPCs. And as with the case with local peering, you always need to configure route tables and security lists. So if I were to draw a very quick architecture, let's say this is region 1, this is region 2. So there is a VCN and there is a VCN B. So you create a dynamic routing gateway on both sides of the connection. So you typically require two dynamic routing gateways here. And then you also need a remote peering connection RPC1 and RPC2 on each DRG in the peering relationship. And then you need connection between those two remote peering connections. So this is how it looks like. So let's now go to the slide deck and reinforce the concepts that we have learned. So as you can see here, there are two Oracle Cloud Infrastructure regions, region 1 and region 2, and there are two VCNs, VCN1 and VCN2. Each VCN is associated with a dynamic routing gateway. You see the two dynamic routing gateways, DRG1 and DRG2. So what exactly is remote peering connection? It's about connecting two different VCNs in two different regions so that the resources can communicate using private IP addresses. So once you create the dynamic routing gateway and attach it to the VCN on both the regions, you also need to create a remote peering connection. So the remote peering connection's job is to act as a connection point. And what we are also going to do is we are going to create a connection between those remote peering connections. The prerequisite that I mentioned at the very start, be it local peering or remote peering, is that the VCNs must have non-overlapping CIDRs. So one thing to note here is that the remote peering connection is typically meant for VCNs that are located in different regions, but technically they can also be used for VCNs in the same region. And there are two ways in which you can use remote peering connection. So if you use the legacy dynamic routing gateways, you will not be able to connect DRGs in different tenancies. So they will support for same tenancy. But in case of upgraded DRGs, they will support connecting DRGs in both same tenancies and different tenancies. Now let's very quickly have a look at the architecture. So you can see that there are two different VCNs in two different regions. I already talked about that. And then there are two different dynamic routing gateways. There's also a remote peering connection on both sides. And then you created a connection between those two remote peering connections. Alright, this marks the end of this lesson where we looked at remote VCN peering. Thanks for watching.